Alright, so let me open up chapter 4. Um, oh, that is not it. Where did it go? That'll be better. Okay. Oh, that's right. I was gonna, because when I write on the board, then the people online can't see it, so I'm gonna use this tablet to, if I need to do any notes. All right. Current slide. Double check that this is. Oh, that didn't work very well. You have to go pointer, options, pen. All right. Cool. Okay, so all our fancy technology here. So let's see, control statements part 1. We left off somewhere around here, talking about if, else, if statements. This time we're going to talk about repetition statements. So a repetition statement is basically it's going to repeat a certain action a certain number of times. So for example, if we do this all the time as humans. So I mean, you got a shopping list, you go to the store, you have to buy them all. Maybe one solution you would do is you would just check one off each at a time, check one off, move on to the next one, check that off, move on to the next one. But you're repeating some action. You're buying objects in this case. The repetition statement body can be one statement. So just like we saw with like an if statement where you can just have a single thing that's happening, or you can have a block, which is going to be then with the curly brackets around it. Now eventually this condition becomes false. Flashing thing is super annoying. I wonder if I can video mute that or something. Oh, that did the opposite of what I wanted to do. I don't know. Now maybe I don't know. We'll just have to deal with the flash. Oh, wow, we actually got both. Okay. Sometimes it works. I'm not sure what the technical issue is there, but anyway. So eventually this while statement that we do is going to become false. The point at which it becomes false, we don't run any more loops on that block. So the way that works is, for example, here's a single line while. It just says while product less than or equal to 100, product equals 3 times product. So this is finding the first power of 3 larger than 100. So basically, while it's less than 100, we just multiply it by 3. But eventually, it's not going to be less than 100 any longer, and this while loop will terminate. When it terminates, it's going to have the answer. So let's see how well this thing works, but I was going to sort of show, I don't know, I've never really done this before, so bear with me. So when you've got a while, that's garbage. I don't want to, I guess I'm going to have to play around with this thing, because I don't really know what I'm doing, apparently. Do I have to go to pointer pen, for example? Wow, maybe I have it turned upside down. Yep, this clearly needs some, this needs to go back to the shop, I guess, as far as I'm concerned, because I don't know what I'm doing. Try one more thing, and if that doesn't work, I'll just ditch the effort. What I'm thinking is I need to go back to pen because I keep pulling it off of there. See, I can do that, but then, there we go. So if we have a while, you can either have, you can have curly brackets around it. That's sort of what I wanted to show. The curly bracket in this part, let me erase this garbage here. The curly bracket in this case would go right here. Wow, I really need, yeah, I've never really tried this, so. But anyway, basically the curly bracket would go, I'll just use this pointer here. Well, actually, they'll be able to see my pointing, so. This while loop, this is where the curly bracket would go at the start of that. And then it would go down here to end it. So basically all I want to show is you can have, just like an if statement, you can have anything you want between those two curly brackets. And normally you're going to have way more than just a single line in a while loop. It's going to be doing extra things. But this while loop progressively goes up by 3, then 9, then 27, 81, 243, etc. And that's how a basic while loop works. Now, if we do something like we don't provide an updater in our while loop, we're going to cause an infinite loop. So this once more, and if this doesn't work, but so if we have a while, if a while product less than 3 or something like this, oops, and these should be not squirrely brackets, but parentheses, yeah. I think the biggest problem I'm having with this is it doesn't automatically go back to pen. I'll have to research that a little bit. We'd have the parentheses there, then we'd have curly brackets here, and we'd have some sort of statement in here like a system outline, system.print.outline. But in this case, this is going to be an infinite loop because while product less than 3, product is never updated. So if product is never updated, you're going to have an infinite loop. And that's all that thing is trying to tell you there. As far as UML goes, the way that looks is basically 4.4 is going to show it, and it's got what's called a merge symbol. So that's the merge point of the this one right here. This is the merge point. So the while comes in, and it says, is my condition true or not? If it's true, then I go in, and that's decided at the decision point. Then I go in and I do this code here. If it's false, I go through and I never do it. And each time I go back from the triple product value here back to the merge point and then the decision point and decide whether or not it's actually still within reason that I should be continuing that loop. So we have to add that additional merge point there. I'm not going to go through all of the algorithms because I'm going to save some of those for next time we meet, but I do want to at least show 4.8, which talks about counter-controlled repetition. So this is a very common way in computer science of going about things. You would basically, and this is what you're going to need for the lab as well. The total is the variable used to accumulate the sum of a bunch of values, for example. And then we'd have a counter separate from that that's used to count up how many times you run through the loop. So for example, in this one, we are, well, grade counter, this is a class average problem. So we're getting a bunch of grades, adding them to the total, and then at the end we're going to divide by the number of grades that we've entered to find the class average of say an exam or a quiz or something. So we set the total to 0 here at the top. We set the grade counter to 1 because we're going to count the number of times that we get a new grade. and that's going to be what we divide by. It's going to be the divisor. So while the grade counter is less than or equal to 10, so we want to get 10 of them, we prompt the user to enter the next grade, input the next grade, add that to the total, and then add 1 to the grade counter. At the very end of the loop, then we say set the class average to the total, divide by 10. This 10 here could easily have been some other value. Whatever value this is going to be what we divide by. So we could have entered in 11 scores or 12 scores or whatever it is, and then we divide by that, and that's just a very common algorithm that's used in a lot of different applications. This is how that looks. This is a grade book with a course name and some setters for the course name, and then determine class average that has a system in, new scanner, which you've seen before, and it just does its grade counter here. So we set that at 1. We process this 10 times. We enter the grade. We get it in. We total it. We add 1 to the grade counter, and we continue on, and then we average it out. So this is the result of that pseudocode I just showed. Now, variables declared inside of that body are local variables, and they can be used anywhere after the point of declaration. So right now, for example, grade counter here is declared. I want to just call attention to grade counter. It's declared down here, and then so it can be used anywhere below this, including this next page. Notice that we've got grade counter again. Well, that can be used there because it was already declared up top. It was already declared right there. So we can keep using grade counter because it's within the scope. We call it being within the scope of this curly bracket. So until we get another curly bracket that matches that, grade counter is valid. That's why, yeah. Did I say something different? That's what I meant. Oh, matches, right. It's until it closes, until there's a matching curly bracket. Yeah, yeah. So at this point down here, that is the matching the closing bracket. So grade counter is no longer valid at that point in time. So that's just scoping rules there. And local variables are only used inside of the methods in which they're created. And this is the driver for that. We've got a main here, and we've just got a my gradebook created, and then we display the message, determine the class average. That's how it ends up looking. Also keep in mind that dividing two integers is going to result in integer division. The fractional part of that calculation is lost. So if we divide 5 by 2, for example, the integer result of that is 2 because it drops off the 0.5. Good thing to keep in mind for things like tests and stuff like that. Type differences like that, like integers dropping off the remainder if you do an integer division. I think I'll keep going for one more section here. This is Sentinel controlled repetition. This is asking us to develop a class averaging problem that processes grades for an arbitrary number. So this is where I was mentioning that 10. Now we're going to make it arbitrary. We're going to say get the Sentinel value, and this is what they call a Sentinel value. So like 12 grades or 100 grades or whatever. That's what we call the flag value, really. The value that we know that we're at the end of this loop. One thing that is a new mistake to make sometimes is that Sentinel value is not the same as an acceptable input value. The input value is different. Input value we get each time we're going through. The Sentinel value always stays the same. So if you're getting 100 grades, that 100 is always going to stay the same through every loop, but you're checking how many, you're checking the tally. How many of these have I done? Have I done 100 yet? If not, do the loop. So as far as, this gets into a little bit of design theory. As far as how you should go about making something like this, the approach that Deitel and Deider are suggesting is this, this top-down, stepwise refinement approach. So this is basically saying we start with pseudocode, and we illustrate what it looks like at the top. So for example, the overall function of the program is to determine the class average for the quiz. So you would write that down first when you're writing pseudocode. Then you refine it into smaller tasks. So this is sort of describing how you'd go about a pseudocode problem. And I'd actually encourage you to think about this or maybe jot it down for the lab, because the lab has you doing, we're getting a little bit more complex now, so you might want to think first about how to do it. The first refinement is we figure out what variables we need. We know that we need the input, the sum, and we need to count the quiz grades. And then we figure out, well, what do we got to do next with that data once we have it? Well, we got to calculate and print the class average. The second refinement in the pseudocode process is committing to specific variables. So the pseudocode statement initialize variables can be refined or enhanced by saying, we're going to initialize the total to 0 and we're going to initialize a counter to 0. This indicates input sum and count the quiz grades. This indicates we need a repetition, but we don't know how many grades are going to be processed. So this is where we know that now we can pull out of our toolbox Sentinel controlled repetition, which is here. So we're going to, this is one of the types of tools that we have at our disposal to take care of this problem. So then after this second refinement, when we've assigned these variables, we have this pseudocode, which says prompt the user to enter the first grade, input the first grade, possibly the Sentinel. So does that make sense? Like why might I want to input the Sentinel too? Well, true. It might, yeah, it might, you might not have anything to enter. Yeah, you might want to stop a little bit at a certain amount of time. Like you know that you're going to have 20 of these or whatever. So so it might be something you want to ask for the user. So then we say, while the user has not yet entered the Sentinel, add this grade to the running total, add one to the grade counter, prompt the user for the next one, then input the next one, the next grade. And then also we can refine our pseudocode even more by where we're saying calculate and print the average. So what they're trying to show you how to do here is basically when you've got a problem statement, because the labs are kind of meant as a confidence booster. I mean, I'm here, I can help you, you can ask questions, you can get help from your friends. But then when you get to the homework and the exam, it's different. We're going to give you a problem statement, like kind of like that global warming quiz thing. And it's going to say like implement this, you know, and it's not going to have pseudocode, and you're going to have to figure out, well, okay, how do I write pseudocode then? So this is just giving you some steps to doing that. When we say calculate and print the class average, then we have to know, well, okay, how do I do that? Well, okay, so if the counter is not equal to 0, set the average to the total divided by the counter, and then print the average. And then in full, the pseudocode looks like this. Why do you think this is important? If counter is not equal to 0, can I say, well, who cares if it is 0? Yeah. Yeah, otherwise you're going to have a 0 divide, because it's possible with the rest of this pseudocode that you could have said user has not entered Sentinel. Well, user could enter the Sentinel of 0, and then the counter was initialized to 0. Counter's never been updated, and then you're going to be dividing by 0. Well, in this case, you'd be dividing 0 by 0, but you're still dividing by 0, and it's still going to give you an error. So then we print the average there. So here's how this looks. Oh, and I should note, this is a good, some programmers do not use program development tools like pseudocode. There are people that insist that they don't need to do a design step, and when you get in industry, try not to be that person. That is very looked down upon these days if you don't know how to do this design of what we just covered with the pseudocode, especially if you're doing something complex. This is kind of bare minimum design. You could have a design that's even more complex than this, where you're drawing diagrams between components and what the inputs and outputs of those components are. That's kind of standard, and I'll probably show some of the designs I'm working on in the professional space at some point. But it is standard now to have some kind of design before you start. Yeah. Yeah. Prompt the user to enter the first grade, input the first grade. Yeah, I mean, I see what you're saying. Like, why not just put that in the loop? Yeah, but you could. I think what you're saying, Greg, right? I think what Greg is saying is that you could have the Sentinel input, but maybe not the grade or something like that. So you can modify the program a little bit to. Right. No, I totally see what you're saying. Like line four could be. I don't agree with line five moving in there though, because you have to. Well, you have to get the Sentinel at some point if you're going to read in the Sentinel. Maybe you're not going to get the Sentinel. Oh, that's how you're interpreting that. That's not how I was interpreting. I was input the first grade, possibly the Sentinel. I was interpreting that as if you want to input the Sentinel as well, you can right there. Oh, I see. Yeah, yeah. Right. So you're just reordering it basically. Right. Right. Yeah. I'm not sure what they're. I mean, because there's definitely more than one ways to do this problem, right? And they just presented one. Um, yeah, the while loop would change. Yeah. 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 Like that's basically saying, well, the user has not got into the Sentinel yet. That part. Right. So yeah, you could reword or you could change that. Yeah. Yeah. The important part is really at the meta level that you've thought about it and you've written this down and you know what you're going to try to accomplish. Because I see that a lot of times where people just want to get right into the code, and then they haven't thought about, are we going to care about the Sentinel or are we not, and then they get to the point where they're writing it and they're making those decisions at that point. It's better to write it down first, even if you're going to do it in Notepad or something. You could do that. So this is the full solution here. So gradebook, set course name, determine class average. So we get the scanner, enter grade or -1, which is the Sentinel to quit. Which again, I think that's why they did it this way, so they could put the Sentinel in there. But again, you could do that differently. We get the next int, and then while the Sentinel value is not met, then we keep reading it. And this is kind of a good introduction to do while as well, which we'll talk about next time. So integer division is going to yield an integer result. What we need to do with that, and they bring this up because this will come up from time to time, you need to temporarily treat those variables that you have as ints as floating point. So we can use cast operators such as double with a left paren and a right paren, and then we can explicitly convert that to a double on that line. So the way that looks is, do we have a, yeah, we have an example coming up here. We can do cast operators in a whole bunch of different things. We can cast from like, ints to doubles, doubles to ints, and it allows us to have one type of a variable that's treated as if it was another type of a variable. Do they not give? I'll give an example if they didn't, but oh, here we have one. Yeah. So here we have the average is the. So average is a double, right there. Note that average is a double because we want. let's say we've got, this is the double average. Let's say we've got a situation where we've got quiz scores, and your quiz scores are going to be some number between 0 and 10. Well, we want the average to be able to display something like 7.5, if that's the average. So we're going to make the average a double, but the grades can only be real number or integer numbered. They can only be 1, 2, 3, 4, 5. They can't have fractional parts. So we take the total, which we're adding up, which is a int. Total is an int right here. We're adding that up, and then we're going to divide that by the grade counter. When you do a double conversion like that, it automatically now treats total as a double, which means that we're dividing a double by an int because grade counter is an int, but it'll promote the grade counter to a double because of the fact that it sees that there's another double that's being involved in the equation. So now you end up with a double divided by a double. So there's two kind of casts going in here. One's explicit, and it says, oh, I've got a total, but I explicitly want to count that as a double. The other one is implicit. This is actually casting to a double, but you don't have to specify that. They made that so because you do it so often that they basically decide we don't have to force the programmers to put the word double in there. Does that make sense? They do have to at least put it in once. Right, then it will implicitly convert it. Yeah, you couldn't just leave it out. Yeah, in that case. Right. Right, like if we did average equals total divide grade counter, we'd be, well, let's see. Yeah, we'd be getting a type error on because we can't implicitly convert that unless we specify double right there on that line. If the average was in, okay. Yeah, you would have to have that be a new variable because you can't do that on the left side, basically, of the equal sign there. And then we'll continue with 4.10 next time. I'm going to go back over to the lab. Just talk about this a little bit. What just happened there? Lost my mouse. Oh, it's way over there. I'll just re-download it, I guess. There we go. All right, so just trying to reinforce some of these loop concepts. We're going to determine whether any of several department store customers have exceeded their credit limits on their charge accounts. So we have an account number, a balance, the total items charged by the customer that month, the total credits applied to the customer that month, and the allowed credit limit. So we input all these as integers, and we calculate the new balance. And that new balance, if it does exceed the credit limit, we would print out that credit limit has been exceeded, such as done here. Credit limit exceeded, for example, because we entered in a 500 balance, 300 in charges, only 125 in credits, and then the credit limit was at 400. Oh. Okay, let me end presentation here.